everyone, today we will be learning about oxidation states. Now let's get started. Oxidation state of an atom. So what is an oxidation state of an atom? It is a charge or a number that is assigned to an atom according to a set of rules, and we'll be looking at the set of rules right now. So the first rule here, it says elements in the elemental state equals to 0, which means any element that is in its elemental state without a charge has an oxidation state of 0. Like for example, magnesium here has an oxidation state of 0. The second rule here says for monoatomic ions, the oxidation state equals a charge on the ion. So for example here, we have magnesium ion and there's a 2+ on the magnesium ion. Therefore, the oxidation state would be 2+, as you can see. Now the third rule here, it says for combined oxygen, the oxidation state equals -2. So for oxygen in its combined form would be -2, except in peroxides where it is -1. So usually, for example, in water we have H2O. So the oxygen in water will have an oxidation state of -2. But in a peroxide, the oxidation state of oxygen is going to be -1. The fourth rule, for combined hydrogen, the oxidation state is +1. And usually, for example, water again, the oxidation state of hydrogen in the water is +1, except in metal hydrides where it is -1. So in metal hydrides, it's going to be -1. Now let's move on. For a polyatomic species, so a species that has more than one kind of atom, example a sulfate ion, the sum of the oxidation states of all the atoms equal the charge on the ion. So for example here we have sulfate, and as you know, the sulfate ion has a charge of -2. Therefore, all of this would equal -2. The oxidation state of the sulfate ion is -2, meaning that the sulfur in the sulfate ion has an oxidation state of +6, as you can see here. So a charge on a monoatomic ion is that over there. Now a change in oxidation state. Now here we have an animation where the atom loses an electron. So increase in oxidation state corresponds to the loss of the electron. That means when this atom loses the electron, it increases its oxidation state. And this process is called oxidation. We remember that oxidation is a loss of the electron. Well, in oxidation, the oxidation state would increase. Now, a change in the oxidation state where the oxidation state decreases is when the electron is gained. So, for example, here, the atom gains an electron. And when it gains an electron, the oxidation state decreases. And this process is called reduction. So the oxidation state decreases under reduction, and we learned that reduction is a gaining of electrons. Now to work out the oxidation state, you would have to remember 2 steps, and these are fundamental rules. The first is oxides have -2 oxidation state. So for example, if you to work out the oxidation state of an atom in a molecule, to first find it out, you would first consider the oxygens in the compound, and all the oxygens would have a -2 oxidation state. The second rule is that hydrogen ions have a +1 oxidation state. So if there are any hydrogens in your molecule, always consider the hydrogens to have a +1 oxidation state. Use these given generalities to deduce the oxidation state. So you would use these generalities to deduce the oxidation state, and these are kind of like rules that you can apply. Determine the oxidation state of chromium in the dichromate ion Cr2O7, and it has a -2 charge. Now this is an example we'll be looking at. The first thing to do is to realize that it is -2, which means the whole molecule has an oxidation state of -2. Now we're looking for chromium here. We have oxygen bonded to it. So one oxide would have a charge of -2, right? So there's 7 of them, which gives us 7 times -2. Now this has to equal, so plus this would equal our chromium 2+. So if you work this out, you get -2 on this side, and then timesing 7 by -2 gives you -14 plus our chromium 2, which we're going to isolate. So to isolate the chromium 2, you would take this to this side, giving us -2 plus 14 equaling the chromium 2. Now to find out the oxidation state of 2 chromium atoms, we would work this out. So -2 plus 14 would give us 12. We have 2 here, so to find the oxidation state of 1 chromium, you would divide this by 2. So you get 1 chromium here, and that'll have 6. So your answer should be 6. Now moving on to the next part, the oxidation states in a summary. Now because this was a very overwhelming lesson, we'll just summarize what we learned. We learned that there are uncombined elements, and these are something like calcium or hydrogen gas like here. And all the uncombined elements would have an oxidation state of 0. And as you can see, here are some examples. The second one we learned was ions. So charged ions would have an oxidation state that's written in the ion. So for example, a calcium ion has 2+. Well, the oxidation state is 2+ as well. And this is very simple. If you turn to your periodic table, and you know you can work out the valences using a periodic table and the groups. Well, the charge of the ion can be worked out that way. That means the oxidation state of ions can be worked out using a periodic table. The third one we looked at was oxygen in compounds. Now oxygen in compounds has 2 different oxidation states. It could either be -2 as in oxides, or -1 as in peroxides. So O in calcium oxide, which is an oxide, has an oxidation state of -2. The fourth one we looked at was hydrogen in compounds. Hydrogen has +1 when combined with nonmetals. So if it's combined with a nonmetal, such as a hydrochloric acid where it's combined with chlorine, it has +1. But when it's combined with a metal, it has -1. So here we have hydrogen sulfide, where the H has an oxidation state of +1, and here we have sodium hydride, where the H has an oxidation state of -1. And again, the last one we looked at was polyatomic ions. With polyatomic ions, the sum of its atoms is the oxidation state. So for example, here we have sulfur and 4 oxygens, and this sulfate ion here has an charge of -2. That means the whole ion or this whole compound will have a -2 oxidation state. Elements with many oxidation states. Now some elements have many oxidation states. In other words, for example, oxygen has 2, while other elements may have many. Many elements exist in different oxidation states in different compounds, so their oxidation state depends on the compound they belong to, and this would equal the variable oxidation state. For example, we have chlorine, which has an oxidation state of 0 in its free state, but 5 other oxidation states in acids. So for example, in hydrochloric acid, its oxidation state is -1, but in its elemental state, it has an oxidation state of 0. Elements with many oxidation states, we looked at a few, but let's take this for example. We have chlorine being in hydrochloric acid, having a -1 oxidation state. In this, however, it has +1, and that's in hypochlorous acid. Now, to work this out, we know that oxygen here has a -2, and we know the hydrogen has a +1 because it's an oxide. Now, +1 minus 2. Now, it has to equal to 0 somehow because this is a whole molecule, and a whole molecule has an oxidation state of 0. That means it has to be +1 in order for this to equal to 0. Now then we have chlorus, which is HClO2, and this has a +3 oxidation state. To work that out, we have 2 oxygens, which gives us an oxidation state for the oxygens as -4. The hydrogen has 1. That means to make this equal to 0, we have to have an oxidation state of +3 for the chlorine. Now with the chloric, we have HClO3. Now that has an oxidation state of +5 for the chlorine. Now to work that out, again you would use a similar step we used here. We know that oxygen has -2 as its oxidation state, and we have 3 of them here, which means -6. And hydrogen, which has a +1 oxidation state. Now all of this has to equal to 0. So for this to equal to 0, we have to plus a 5 here, like that. And that's why chlorine here has an oxidation state of +5. Now perchloric acid. Perchloric acid has 4 oxygens, 1 chlorine and 1 hydrogen. And apparently it has an oxidation state of +7. So to work it out, we have 4 oxygens here, and 4 times 2 is 8, so we have -8 oxidation state. Then the hydrogen has +1. To make the whole thing equal to 0, you have to +7, and that +7 goes towards the chlorine. So chlorine has an oxidation state of +7. Now that's how you would be working out the oxidation state of any atom in a compound. Now, close relationship between the possible oxidation states of an element and its position on the periodic table. Now there is a close relationship, and we'll be looking towards that. For example, we have elements with multiple valence electrons, such as chlorine, so that can have many oxidation states, as you just saw. Transition metals commonly display a range of positive oxidation states in their compound. Because usually they're all metals, they have a positive oxidation state. So for example, we have manganese that can have an oxidation state of +2, +3, +4, +6 and +7. So it depends on the compound it is in, and manganese varies its oxidation state depending on its compound. By examining a variety of redox reactions, it can be seen that oxidation involves an increase in oxidation states. Now we'll be looking at why oxidation is involving an increase in oxidation state here, and we would be examining redox reactions to monitor this. Do you remember that redox reactions we covered earlier was reduction and oxidation reactions put together or happening simultaneously? So let's look at this. This is because an atom must lose electrons to increase its oxidation state. Now oxidation states would increase if it gains a number. So for example, from going +2 to +3, it's gaining a number upwards from the scale. So that means it has to lose a -1. So to lose a -1, you will be taking away a -1. So +2 take away a -1 would give us +3. So to take away a -1, you'd have to take away an electron. And that's why when you're losing an electron, there's an increase in the oxidation state. Conversely, reduction involves a decrease in oxidation state. So the opposite happens in a reduction reaction. In a reduction reaction, you're gaining an electron. That means a +2 is gonna not minus but gain, so it'll plus a -1, which means +2 plus a -1 would give us +2 minus 1, which is +1. So it has reduced its oxidation state or decreased its oxidation state. And that's how the oxidation reactions and redox reactions and oxidation states have something in common. So for example, now we're looking at the burning of magnesium metal. We have magnesium here in its solid form reacting with oxygen gas. When they react, they form magnesium oxide as solid. The magnesium is oxidized because it has lost electrons. Now, how do you work this out? If you look at the magnesium here, it forms an ion, which means it's going to be positively charged here. So in order for this neutral particle to be positively charged, it has to lose electrons or negative particles. And vice versa is happening for the oxygen, which is gaining electrons. Now let's look at this. We have magnesium going into magnesium ions, and in this process it would be losing 2 electrons. Now the oxidation state of an elemental metal is 0, and when it loses the electron, it becomes an ion with a +2 charge, which means its oxidation state is +2. So we can see an increase in oxidation state. So what does that mean? The oxygen, which is reduced, shows a decrease in oxidation state. Now we just looked at magnesium, which has an increase in oxidation state. Looking at oxygen now. Oxygen now is gaining 4 electrons. When oxygen gains 4 electrons, it's going to form an oxygen ion. Now note the oxygen ion is an anion, which means it's negatively charged. So from 0, it's going to -2. That means it's decreasing, therefore undergoing reduction. The number of electrons gained or lost corresponds to the change in the oxidation state of the atoms involved. So that change in the oxidation state is corresponding to the number of electrons lost or gained. Now in this topic, we just covered the oxidation states. We learned what oxidation states are and also how to calculate oxidation states of certain compounds. Now let's look at some questions. Here we have question 6. Which change in oxidation number indicates oxidation? Now what's oxidation? Going back to our oil rig, we remember it's a loss of electrons. So anything that is losing electrons is undergoing oxidation. So for something to lose electrons, its oxidation state must be increasing. So let's take each option one by one. We have option A. Going from +1 to -2, it is decreasing by 3, which means it's not undergoing oxidation. So option A is not correct. Going to option C now. Option C is -1 to -3. Now again, the oxidation state is decreasing by 2, which means it is not losing electrons. In fact, it is gaining 2 electrons. So clearly, C is not the correct answer. Now moving to option D. Option D is +2 to +1. The oxidation state decreases by 1. Again, it is gaining electrons. So for that reason, it is not undergoing oxidation. Now moving to option B, which is -1 to +3. Oxidation is the loss of electrons, which means the oxidation state increases. And you can see it's increasing here. Therefore, option B is the answer. Now let's look at question 7. Iron occurs in compounds such as iron oxide, iron 3 oxide, iron sulfate, and iron chloride. Based on this information, which of the following statements is most correct? Now we have 4 options here and we'll be considering each one by one. Now considering option A first, the oxidation state of iron atoms is always +2. Now is that correct? Because we're talking about iron atoms here, and iron in its elemental form has an oxidation state of 0. So option A is not the correct answer. Now moving to option B, the oxidation state of iron atoms can be either +2 or +3. Again, we're talking about iron atoms. Iron atoms are in its elemental form, which means that B is incorrect. Moving to option C, the oxidation state of ions can be either -2 or -3. Now iron is a metal and it has a positive oxidation state. So it can either be +2 or +3, but it cannot be -2 or -3. And as you can see here, oxygen has -2, therefore this has to have +2. So from there you can work out that it's either +2 or it can be +3 in this case. So let's consider option D now. The oxidation state of an ion can be +2 or +3, and that is correct. Ions have a non-zero oxidation state and atoms have 0 oxidation state. Ion is a cation of ionic compounds, so must have a positive oxidation state. Therefore, D is the correct answer. Now moving to question 8. Question 8 says, the oxidation state of zinc is shown by the equation. We have zinc reacting to form zinc the ion and 2 electrons. Now during this reaction, the oxidation state changes from 0 for zinc to +2 for the zinc ion. Describes and account for this change in oxidation state. So you'd have to describe and account, and these are the 2 key verbs in our question: to describe and account for the change in oxidation state. Now let's take one by one. The oxidation state for zinc has increased from 0 to +2. Now an increase in oxidation state means zinc has underwent oxidation, losing valence electrons from the neutral atom and gaining a net positive charge in the ion form. So this is the answer you would be going to. Because it has increased from 0 to +2, it is losing valence electrons, therefore gaining a net positive charge in the ions formed. And that's your answer for question 8. Now let's move to question 9. Question 9 is asking, the equation shows a redox reaction. So we have chlorine reacting with potassium bromide to form potassium chloride ions and bromine the liquid. What is the change of oxidation number of chlorine? So we have chlorine here having an oxidation number of 0 because chlorine is in its elemental state, so 0. And then it changes its oxidation state. Now look at it. From neutral chlorine is Cl2 to Cl-1. So the oxidation state changes will be from 0 to -1. So there is a drop in one oxidation state. Now let's move to question 10. What is the oxidation number of manganese in manganese hydroxide? Now note there is a 3 here, We know that the hydroxide ion has a valency of -1, meaning that manganese has a valency of +3 in this case. The oxidation state for oxide is -2 and hydrogen ions is +1. So you can see that hydrogen and oxygen here, -2 for this, +1 for there, and in whole it has a -1 charge. So to work out the manganese oxidation state, you would +3 times it by -2 + 1, which all equals 0. So you would move around the equations to get manganese as +3. Now that brings us to the end of the lesson. We covered oxidation states in this module, and we also considered 5 questions that could come from this section. We also learned how to work out the oxidation states of different compounds and looked at the oxidation states of oxygen and hydrogen in particular.